probably 5 after. Oh, warning, warning. Okay, recording, and I want to share my tropical island. So this is a picture of Roland's house, it looks like. So that's pretty great. And now fire that up. Yay. Do we have slides today?
Yes.
Good. Okay. I talked for like 10 minutes and no one told me I didn't have any slides. So, okay. All right, let's kick it off. So welcome to the October 4th edition of Denver Erlang Elixir Meetup. Woohoo! Oh, come on, seriously? All right, this is recorded. We'll try to upload it to YouTube for posterity so generations to come can enjoy its content. What are we doing tonight? I'm gonna make some announcements. We do have a beginner's talk. We have a main talk, hopefully. Opportunity for show and tell. And then we'll hang out in Zoom in little breakout rooms. Shout out to our sponsors the Zoom and pays the meetup fee. So yay, go pay it off. My favorite company because they sponsor me too. So yay. Who makes this happen? It's a random group of organizers. So there's Jeff, Jeffrey, Alexandra, me, and Dylan in no particular order. How can you get a hold of us? Well, we have a presence on meetup.com, which is where we announce all of the meetings and put details for that. We don't really participate much in the Denver's channel aside from telling people to go to our Slack channel, which the enrollment for that Slack channel is actually in the Denver channel. Feel free to put questions in the chat here if I confuse you with that. But basically, we have our own channel that's dedicated and doesn't go away anywhere near as quickly as the public channels. So that's why we have it. All right, so each month we ask a handful of questions to do virtual networking. So off the top, is there anybody hiring? Since Jeffrey's not here.
I can probably talk about hiring at community. I believe we do have some roles open for a team lead writing Elixir, and I think a team lead for data. So I can, if anybody has questions about just what's happening, please feel free to reach out to me or Jeffrey Matthias, and we'd be happy to get you set up.
Cool. By the way, we do have a jobs channel in the Slack, so we try to post links there when jobs are posted, because they do come up from time to time locally. But if you also have a link, know somebody's got a job, if you want to post something in there, that would be helpful to others. Anybody else hiring? Okay. Anybody looking?
I am.
You being, sorry, I didn't see who that was.
Oh, pardon?
Oh, is that Caleb? Is that you?
Hang on, sorry. I'm sorry, what was that?
Is there anyone looking for employment in the Elixir Erlang field?
I certainly am.
Okay. So.
My son, David Crayman, is looking. He's
okay.
not, he didn't join today, but I know he's looking.
Couple guys. All right. I will refer you to the aforementioned channel or the hiring guy if you're looking for some candidates. We got them. Anybody else looking? No. All right. Fair enough. Okay. It's my monthly call for speakers. We can't do this without you or without Shanghaiing your friends to give us some content to share. I hopefully have a speaker lined up for next month, but we have great opportunities for beginner track. We haven't had those for a while. So if you want to dip your toes and see if it might be a fun thing to try, or you want to investigate something, it's a great way to force yourself to learn something. If you would like to speak, we are happy to coach you, give you some pointers, support you in any way we can. If you reach out to the organizers in the aforementioned Slack channels, it's probably the best way to do it. Or you could message us on Meetup if you don't want to join the Slack for whatever reason. So we are always looking for new content. We actually, I believe one of our speakers is going to be talking at ElixirConf next week. So if you are thinking of doing a conference talk, it's a great way to practice your talk as well. So a great opportunity. Any general announcements? All righty. Here's the slide that Mark made me make last month that I'm recycling. So next week in Austin, Texas, you can either fly down for a few days of in-person Elixir fun or online. You can join later in the week. And we were just chatting with Roland earlier what the benefits of that are. That is left to the user as an exercise. Certainly being in person is nice, but I know a lot of people are still a little uncertain about meeting up in the flesh. So you have opportunities either way. So I suspect, certainly for the virtual, I'm sure that one still has tickets available. I have no idea if they do for in-person, but I wouldn't be surprised if they did. So coming up, tickets running out. Also, the following month, next month, gosh, is it? Gosh, it's October. Okay, so next month, about a week from, or a month from now, is Codebeam America. This used to be Erlang Factory, so slightly more Erlangish focused, but it's really all things Beam. So you get some Elixir, get some Erlang. You might even get Gleam or LFE or other Beam-related languages, and that is completely virtual. So I have signed up for that one myself. Because I haven't gone in like a long time, and it was great when I went, but it was in person. So I'll report back in December to see how great it was. Had a little experiment last week. Mark and I had a lovely dinner out at Wincoop, but nobody else showed up. So we'll give that a rest for a few months until people are more interested in actually meeting up in the flesh. It was outside, so it was good, relatively safe, lots of opportunity for social distancing, but as the weather turns, we might have to wait until spring, or I don't know, second, third jabs or something, whatever. So anyway, we'll do it again at some point when people are ready. Okay, so a little more detail. What is show and tell? So if you have a little side project, problem you're working on at work, question, something cool you discovered that you wanted to share, you can share it with the group. So it's really just a conversation opportunity for you to share whatever you want, Beam related. So we'll open that up after our speakers. And then finally, we'll have Zoom breakout rooms and have an opportunity to have a little more socialization, even though it's online. So it works reasonably well, better than I thought it would. So it's good. All right, so we have two guest stars today. Roland is going to be enlightening us about time zones and dates, and Chris is going to be talking about Elixir performance, as I recall. So without further ado, I will turn this thing off. Okay, great. Turn that thing off. There we go. Yay. I'm back, and I will hand it over to Roland and really hope that, oh, Chris is there. Yay, good. And Chris, I'll let you introduce yourself, or sorry, Roland, you go first. Introduce yourself, and I hand it over to you. But you will have to unmute, I'm afraid.
Yes.
Thank you, sir.
Also, hide my video panel so you're not afflicted by black splotches. So I'm Roland. I live in Honolulu.
Nice.
No one else lives in Honolulu. And so I have to schedule a lot of meetings in other time zones, which is a bit of a hassle. And so I thought, I'll build an Elixir application to solve that problem. And we read through the date time documentation. There's this excellent function called shift zone, which takes a date and a time zone and converts it for you. Great, problem solved. Error, I need a time zone database. Where do I get one of those? Well, Elixir comes with one. It's the UTC only time zone database. This is great, but I can't convert to mountain time to know when I'm supposed to give this talk. So it's not really helpful to me. And so one thing I could do is I could call up the mountain time people and ask them what their offset is and figure out how to convert or do other things. But thankfully, there's a group that's already done this for me called the Internet Assigned Numbers Authority, IANA, and they package up all the time zones around the world in something called TZ data, so that developers like you and me don't have to struggle as much trying to wrangle time zones. Thankfully, Elixir has taken this a step further, introducing TZ or TZ, is a library wrapped around the IANA TZ data database that makes it really easy to use worldwide time zones in Elixir. So I can add that to my dependencies, and then I can call tz.timezone_database in the function before, and it works. I now know when I'm supposed to give this talk. But it's a bit tedious to add tz.timezone_database to all of my function calls, although I'll admit that's actually what I did in my application. You can add it to your config, so config/config.exs. You can set timezone_database as tz.timezone_database, and they'll just set as the default for all of your function calls in your application at compile time. Now, maybe you need to set your time zone database after compile time. Calendar's got you covered. There's a put time zone database function, which is useful if you need to say, update your time zone database. In the last 20 years, Venezuela has just arbitrarily decided to change their time zone by 30 minutes without even telling IANA that they were going to do this, which caused all of their developers a whole bunch of hell and heartache. Thankfully, as long as Venezuela tells IANA that they're going to do this, there's a helper function, tz.update periodically, which will listen to TZ data for changes and then download and update your time zone database automatically for you. But maybe it's not the best idea to let external resources automatically change your code. And so there's another helper function called watch periodically, which just notifies you when there's a change to TZ data, and then you can choose what to do with that notification yourself. Both of these functions will require Mint as a dependency, as an HTTP server to reach out and grab the TZ data update or notification as necessary. I highly recommend reading the TZ hex docs. The README is quite thorough and includes great information like how to avoid running that update when you're testing your application, how to set a custom HTTP client. I'm already using Phoenix, or I know I already have an HTTP client. Why do I need to add Mint as an extra dependency on my project? Well, you don't, as long as you follow the instructions. And this last one is interesting. For my application, I only care about setting meetings in the future. So I don't need a whole bunch of historical time zones. And TZ has an option that allows you to remove, say, all time zones from 1970 to 2015, and then it'll speed up your compile time because it doesn't have to parse all of those TZ data files or to get the right things for Elixir. I highly recommend this article called Falsehoods Programmers Believe About Time Zones, which explains in great detail why you would go to all the trouble of creating TZ data and using TZ as a library instead of just adding and subtracting UTC offsets. It's a mess, don't do it, trust the library. Thank you.
All right, thank you. I'll unmute myself so that I can thank you for that and then throw questions your way. So first off, do you happen to have a link to said article?
Not on hand, but I can get it in chat later.
All right, that would be useful. That was cool. See, look, pain-free, easy intro talk, not that hard. It was good. Thank you very much for that, Roland. I was curious though, if you've used the Timex library.
So Timex is really good at humanizing dates, like parsing strings and turning them into human forms. I ultimately decided not to do that because it's for me. And so I'm not humanizing dates for anyone but me. But really the time zones are separate from timex. Part of the reason that the TZ library exists in the first place is so that you don't have to update Elixir every time TZ updates. That's why they decided to keep it as a package rather than integrating it directly into Elixir.
But are you manually having to do this update, as you say, the alert, the time? I mean, you have to configure it to go shopping for the new time zones, right?
I don't understand your question.
Sure. Okay. So it refreshes it. Does it just automatically refresh itself? I was a little confused when you said there's like, you'll either have it pull or it notifies you. Is that like a config option? And then at build time, it will poll the server, or?
So the update function that I mentioned before, you add to your supervisor. It'll just
Oh,
run
right. Got
over
it.
time. And then for my application, I'm not actually asking the user for anything. It's just a statically rendered HTTP process. I'll show it off during the show and tell later if you have more questions. I thought that the interesting parts of the component weren't the time zones, but were the non-Phoenix web stack that I decided to use. And so I decided to keep it separate from the talk.
Cool. Anybody else have any questions? All right. Thanks again, Roland. Appreciate that. And we will slide seamlessly over to Chris, who will illuminate us on some other cool optimization for Elixir. Yes.
That is the general hope and plan. We'll
All
see if
right.
we get there.
You sound a little quiet. I'm wondering if
1 moment, test.
I can hear you. You're just quieter than everybody else. So
How about now? Better?
hey, it's fine. Yep.
All right.
Everybody.
Cool. Everybody can hear me, hopefully.
Yep.
All right, so I'm going to be giving a talk next week on kind of the basics of performance and kind of like what that looks like in the Beam. And so our kind of, I'm still hashing out exactly how I want the talk to flow. So this is going to be a little bit half digested. I apologize for vomiting knowledge at you. If indeed it is all knowledge, we shall see. Our sort of framing device is that I do a fair amount of what I consider kind of numerical programming in Elixir, mostly because I enjoy doing gaming and graphics and physics and that sort of thing. And one of the things that's very cool about Elixir is that as a functional language derived from Erlang, it gives us really, really nice tools for writing really, really elegant, clean code for like banging numbers together. However, kind of the original sin of the Beam is that it doesn't actually like banging numbers together. And there's like maybe 30 years of hardware and developments that we don't get access to because we're on the Beam. So it's very important on us to write as performant code as possible. One of the things that I mean by that is that if you look at Fortran or C or Rust or arguably even Go, although I'm not sure about that. Some of the JavaScript optimizations you get with like typed arrays. There are a lot of instructions in the CPU that are called SIMD, so single instruction, multiple data. And what they are very good at is operating on a bunch of numbers in parallel. In particular for us, we're going to be focusing on adding some vectors together. And without going too hard into linear algebra or anything like that, I'm going to assert that this is a worthwhile operation for a computer to be able to do. And then we will kind of dive into figuring out how good like our platform of choice is at that. So ignore that. That's not important. 1 moment. So our first kind of setup is when we talk about adding two vectors together. A vector is really just a tuple and of like, one or more elements. So like, we have our first vector v1 equals a, b. V2 is equal to, c and d. Is everybody able to read this, by the way? I know I'm kind of sensitive to like font size. So is this nice and legible for everyone?
Size is good.
All right, fantastic. Let me fight with Zoom a little bit, or maybe not. We all tend to lose arguments with Zoom. All right, and then we have our, vector out is going to be equal to, a v1 plus v2, which resolves to a plus c, and then b plus d. As you can imagine, there are several ways of implementing an Elixir function to do this. And what's kind of neat to us is that as we're trying to figure out like the best way of implementing this, because again, we don't have that hardware support for doing all of this in one shot. Right now, if you look inside of a CPU, we have these SIMD instructions that will take several registers and then in basically like a few machine cycles, add everything together. And if you think about all of the stuff that we have to do in Elixir to actually make our CPU, like at the very lowest level, do things, we expect a lot of extra instructions and fluff to be added. So again, the reason we care about this is we want to figure out how much fluff is actually being generated and how we can avoid it. So the way we're going to tackle this problem is that first we're going to look at some different ways of implementing adding two vectors together. Then we're going to go ahead and we're going to look at, what code do we expect that to generate? And then finally, we're going to go ahead and we're going to profile it. And we're going to actually see like, okay, what is actually the fastest way of bashing some vectors together? So as kind of a starting point, would anybody like, I'm going to go with like a little more interactive version of this than I'm going to probably be doing next week, because I've only got like 20 minutes next week. So would anybody like to suggest a function? We're just going to, we're just going to throw out some ideas here. Would anybody like to suggest a function for banging together some tuples?
I'll bite. Let me know
All right.
when you're ready.
Just about ready. Tuple mesh.
Oh, very, very seasonal appropriate.
So let's start by assuming that these are two tuples. So how would we how do we want to what should I type?
Yeah. So I assume that on line 3, this function head will be an arity2 function.
Mhm.
Argument 1 will be a 2 tuple, and argument 2 will be a 2 tuple.
Oh, okay. And so first question is, do we want to go ahead and explicitly destructure those in the function head or not?
Since this is a performance talk, I have been led to believe that pattern matching is very fast. So let's cut that corner and let's do it.
All right, fantastic. So we're just going to go ahead and implement that really quickly. Sweet. And then what do we type? We're just adding the components together, right?
We'll have element 1 of this new 2 tuple be x1 plus x2,
Mhm.
and then y1 plus y2.
Solid. So this is one way of this is by inspection. I will verify, yes, that is the correct way of bashing together 2D vectors if they're encoded as tuples. So in Elixir, what's another way that we could express the idea of these vectors that might want to get mushed together? If they're not tuples, what's another way that we can store lists of stuff in Elixir?
And I'm on the nose. Would they be lists that are length of 2?
They may indeed be lists of length 2. That is absolutely correct. So we're going to go ahead. It's so great to have a friendly audience.
Yeah.
And then we're just going to go ahead and mush these, right? Y1 plus Y2, and it's mad at us. There we go. Cool. And then if you wanted to be very silly about it, you could go to its logical conclusion and say, okay, and then we're just going to do, edom.reduce, and then that's going to be like, we're going to take A and B, because that's totally fine. And then we're going to take a function, and that takes what, an accumulator and an element. So
I think it's the element first.
Element first. So X and Y, and the accumulator, which is X out, Y out. Typing Y out actually pained me because I kept wanting to write U.
And
Cool.
do you
Yout.
need to specify the accumulator when you kick off reduce on line 12? Is that the second argument?
Absolutely do. That is correct.
Okay.
Oh,
I think it's
It's accumulator then function.
yes.
Accumulator function. I
believe
always
so.
I always get that mixed up with JavaScript, I think. Because I think they swap those two arguments. Cool. And so now we have enum reduce. Oh, come on. And it's probably upset because we haven't returned anything. So we're going to return X out plus X, Y out plus Y. And there, that should make it happy. What is it complaining about? No.
You're missing a parentheses on the closing reduce.
Excellent, thank you. Cool. So here we have 3 different ways of skinning this pistachio nut. And then we're going to compile that. Yay. And so our intuition is that, I mean, at least my intuition is that tuples tend to be the fastest things, followed by lists. The reason that this is that tuples store a bunch of things in contiguous memory. A list as implemented on the beam is going to be it's kind of a Lisp style list where you have the element and then you have the next thing in the list, or nil if it's a length 1 list. And then add reduce is going to, I think this is going to be slower, probably because it has to make a bunch of function invocations. So that's kind of what we think is going to happen. So our next step is having set up kind of our thing here. Let's go ahead and let's look at what actual bytecode has been generated by our friend. And this is using a fork of, I forget the name of the fellow. I feel bad because I've submitted a patch upstream about it. Beam DSM, which is a beam file disassembler. So whenever you go ahead and actually compile some Elixir code, you'll probably notice that there is in the build folder, which we basically don't interact with other than removing it when something doesn't seem to be working right in our daily lives as web developers. That's the other. That's my other slight grump is that my day job is using Elixir for web stuff. That's been what I've been doing with Elixir for many years now. I only get to do fun stuff on the side with numbers. One day. Anyway, you'll see that we have here basically, we have our project performance, cool. We have our mix stuff, which we don't really care about. We have our consolidated stuff, which is, I think, pulled in from elsewhere during compilation. And then we have eben, which is what was actually generated as part of our work. So we have elixir tuple mash.beam. So it's, the module name .beam. And what we're going to do is we're just going to crack that open and we're going to go see what code it generated. Was that a sigh of relief or consternation?
No, it was good. Carry on, sorry.
So we're going to go ahead and grab our tuple mash. I'm going to scream a little inside. That's okay. Just a little bit of light screaming inside. And luckily for us, we have a why you do this to me?
Trying to open the beam files or what?
Oh, yeah, no, I'm trying to open the beam files, but I'm a dummy and I forgot that. Yeah.
Whoa. I didn't know
you
you
gotta
could do
right click
that.
and do a thing. So this is, again, this is provided by the Beam DASM, which provides a much friendlier interface over a pile of really, really fascinating Erlang system commands that you can use to just, rip and tear your way through a Beam file to figure out what the heck's going on. I'll probably mention those in my talk on a slide of like, if you want to tear apart this manually, please consult blah. This nice person built it into, cribbed off of the specs for this stuff and then built a nice friendly Visual Studio plugin for it disassembly really wants to have like an IDE. So anyway, these things are made of a bunch of chunks. The stuff that we care about is that we are on Elixir 20, we are on Erlang 24 and Elixir 13. These are the bytecode for it. And what we see here, and I'm going to open up another tab so we can more easily compare a couple of these. Let me. Yeah, that works. That works. All right, cool. We're gonna hide some of that just cause. So first, we're just gonna kind of skim this. So our first version, remember, we have our. Let's look at add tuple. So it says function elixir tuple mash info. So this is your basic, what's going on in my file. And if y'all run into this, we're going to have tuple mash info, but and it expects you to actually ask for something. And you'll see that here where it's going to, select value. And this person who wrote this, it's very nice. He even built in the documentation for the different opcodes, which is very handy. So, here's, check this first argument, and then depending on what it is, go to the right place. And that's kind of fun. I don't know these opcodes offhand, but anyway, this is info. This is where you're going to get your normal module info stuff. Add list is going to be our first actual, well, we have add list and add tuple. So we have add tuple here. And so we're already seeing something kind of interesting, right? So what does add tuple do? I'm going to pick this because it's pretty easy to read. We have these labels off to the side, and these are, how many of y'all have ever used BASIC or used GoTos or done assembly programming? I'm going to assume at least one person raised their hand. Excellent, brilliant.
Handful.
So one of the things is that when you get down to like the low level of an interpreter and like these things down at like the assembly level, you end up with something that looks a lot like, do this. If this works, go to this label. If this doesn't work, go to this other label. So that's why we have these nice little labels here. So first one is a func info block that's going to tell us, hey, this function is called tuple mash, is in the Elixir tuple mash module. Its name is add tuple, and it is arity 2. So that's kind of cool. Then we have, x sub 0 is our first register. So we're going to say, is a tuple, is x sub 0 a tuple? If it's not, we're going to go to label 12. Test arity, same sort of thing. We're going to say, okay, is x sub 2 like actually a tuple? If it is, great. Otherwise, go somewhere. So this first, this is where we handle basically our guard clauses. The next thing we're going to do is we're going to extract the first element from the first argument, from the first tuple, and store it into x2. We're going to extract the first argument from the second element, from the second argument, and store it into 3. So you'll notice that we're passing around our arguments on the stack, in the registers. If I remember correctly, the maximum number of arguments you can pass to a function in Elixir/Erlang is 255, and it's a 255 register VM, I believe. So this is not a coincidence, right? We're passing all of our arguments on as registers. An alternate way of doing this would be using a stack. So if you look at a stack machine like you might have with, famously x86, or what you might run into in like a fourth dialect or something, FORTH, which is a whole another fun little weird evolutionary offshoot of programming. Anyway, that's maybe unbounded in terms of the amount of stuff you can push on and off the stack. I mean, depending what memory allows. For us, we use what's called a register machine as opposed to a stack machine, where we have all these registers, which can be thought of as, the machine state could be thought of as a tuple with 255 elements, and then just, they slot stuff in depending on what you need. So once we've pulled that stuff in, we're going to invoke a BIF. So what we're going to do is we're going to say, okay, we want to execute good old Erlang plus, which is, just how you bash two numbers together. And we're going to bash together x2 and x3. and which we stored here, and we're going to store the result into x2. Then we're going to do that same fetch again. So this was that first chunk of getting the first part of the tuple. Then we're going to process the second part of the tuple the same way. And then our last act is we're going to go ahead and we are going to make sure that we can actually allocate some stuff. That's the test heap that comes up here. And then we're going to put on our out on x0, we're going to put a tuple of x2 and x0. So that is how we do this as using tuples. Anybody want to? I'm going to pause and give a chance for people to ask questions. I may be able to answer them. I may not. If I'm going a little too far down into this, please let me know so I can pull up a little bit.
Got a question.
All right. Well, happy to answer questions.
So we just enumerated through all of these instructions.
Mhm.
Do we know if each of these instructions cost the same amount? Are they each equivalent?
So that is a very good question. And the way to answer that question is to look into the Beam source code. I don't know offhand what the timings are for these different instructions. I'm pretty sure that some of these instructions, so if you look at test arity, I would expect this to be a relatively cheap function, a relatively cheap instruction, because it's going to go and check a C structure or something and just check an arity. So it should be relatively cheap. Something like GCBIF2, potentially this is a trampoline, right? It's going to go and it's going to implement, it's going to actually invoke some other code. And it would not surprise me if this code is particularly expensive. This could take many more cycles. So to answer in short, I don't know offhand what the timings for the opcodes are. I suspect that they are definitely different depending on what they're doing and what they might be calling out to.
Thank you.
Cool. So if we go ahead and we look at, are there other questions, or are we good? I can't see everybody because of Zoom. So.
Yeah. I'm a little curious. I was an Elixir dev for a while, but I or for a short period of time doing contract work. But these .beam files, I know that Elixir is basically syntactic sugar on Erlang, but what is the relationship of these .beam files to the beam? Maybe that's a little bit too general of a question, but what is the relationship of the files say to the Erlang source?
Sure. So what happens is that the Erlang source compiles to Beam files, as does the Elixir source code. And the Beam files is it's what's known as, I kind of think of it as an IR, so intermediate representation. So it's not the lowest level stuff, it's the next lowest level. It's the assembly language that then gets executed on the machine. Well, linked and then executed. And so Erlang will compile down to this, Elixir will compile down to this, LFE, I think, will eventually get to this, your favorite Beam stuff of choice. All of the Beam languages end up as Beam files, and then these are run through the interpreter or compiler, depending. And this is kind of the last stop before optimization happens. So certain types of low-level optimizations, what are called peephole optimizations, and that's stuff removing dead code, removing certain types of redundant operations, that sort of thing. That's where that will happen. So that'll happen after this stage, but right here you can get a feel for roughly what's going to be going on with the function. So it goes, Elixir Erlang source code, Beam, compiled thingy that we'll mess with. I believe that to be the case. Let me know if I'm wrong.
Okay, so this is basically the machine code for the Beam, so to speak.
This is the machine code for the stuff that's going to be executed. So it's not the Beam itself. This is the stuff this is the program you feed to the Beam. Does that make sense?
Gotcha.
The source code for the Beam itself is generated by C and, as it turns out, Perl, and some other things. Cool. Any other questions, or can I trundle forward?
for it.
Cool. Okay, so we looked at our, add tuple, and then we're going to go ahead and we're going to look at add list, and we're going to say, oh, okay, cool. So, same sort of setup. Here's our function. Here it's going to tell us our info, what module it is, the function name, the arity. Great, good old MFA, love it. We're going to make sure that our lists aren't empty. And this is kind of fun here because what we're seeing is that if we look at our source code, there's a bunch of implicit assumptions in add list, right? First, that we have 2 arguments, that they're actually lists, that they actually exist, and some other things. And here we see laid bare that, like, yeah, no, we've got to make sure that it's a list that isn't empty. Then we have to, parse that list out into our registers. We've got to make sure that it is, like all of the parts are what we need them to be. So there's a whole bunch of, comparatively, a whole bunch of ceremony before we get to actually just, bashing these numbers together. So that's kind of interesting. I think that this, I'm not 100%, but I'm pretty sure that another valid structuring of this would have had these happening up here. Compiler decided not to do it. We have our test heap to make sure that we have a place to put stuff out. We're going to store we're going to store a list, our list, we've stored out as a list. And so again, we see that form of, oh, hey, we're going to go put a list here, and, it's going to have that, no, like a next item of nil, and then the current item. Cool. And then we're going to have, again, put list here. X0 is where we put stuff out. It appears that X0 is, I think, the return register for Erlang functions and Elixir functions. I'm not 100% on that, but it seems reasonable. And then again, we're going to, replace X0 with a list consisting of the value stored at X0, which was calculated up here, and then the next element of X1, that list. And then we're going to, boop, return it. So again, we see that the actual meat of bashing the numbers together is these 2 BIFs plus, same in both, no big deal. Lot more ceremony over here. And then the one that I did not expect at all is when we call reduce, you'll notice this is actually really, really, really short. So that's kind of fascinating to me. It's like, why is this so short? Well, let's go look at the function again. Add reduce, it takes 2 lists, or rather, it checks that A and B are both lists, invokes reduce. Okay, why is this shorter? And it says, well, yeah, let's make sure both arguments are a list. Okay, that's our guard clauses, became this stuff. We're going to make sure that we have a test heap to return things. Okay, cool. Make fun 3. I like 3 here because I'm pretty sure that means this is their 3rd attempt at, like, making a make function argument. So that's kind of cool, I guess. And then it's going to initialize it with, it's going to store it into X2, I think, with, an empty accumulator. So that corresponds to this bit right here, right? We're going to then stuff our stuff together and call reduce on ourselves using that. So that's kind of neat. Yeah. So for whatever reason, this is fewer operations. So that's kind of our, that second step was we thought about it. Then the second step was we looked at the disassembly and we said, oh, okay, I'm pretty sure now, I thought tuple was going to be the fastest, but it looks like add reduce is at least the fewest instructions. So unless these instructions are grossly slower or grossly different in timings, then we can say, oh yeah, okay, so it looks like, I'm not going to change my bet. I'm going to take my money off add tuple. I'm going to say add reduce is probably the faster function. So then what we're going to do is now we're going to, now we've kind of made up our minds, now we actually have to test it. We're actually going to try out stuff. And that's kind of where all of this ultimately comes down to, is that we can make some very good guesses about what we think the code is going to do and what we think the compiler should do and what we think the interpreter should do. But at the end of the day, you actually have to measure the damn thing. And what we're going to be using for that, there is a built-in function called timer timer RC. And so that is here. That is something like, timer TC. And that returns your time in micros. If you just do MFA style, then that's going to be something like, I don't know, Erlang is a good module. Plus is a good function. Arguments are 1 and 2. It's pretty fast. All right, it did it in a microsecond. I like that. Yay, and it returned 3. Okay, cool. If we wanted to, do something more exotic, you might imagine that you're going to be timing your custom module that's doing like a whole bunch of stuff. So in our case, we're going to go ahead and we're going to call, this time we're going to call, tuple mash. We're going to call add list, and we're going to call that with, 0, 0, and 1, 1, or 1, 1. Okay, cool. And now it's grumpy at us because it's like, hey, what are you talking about? Add list, and we're like, I'm sorry, I meant add list 2. No, it's still upset at me.
To be an atom.
Boom, nailed it. Thank you, sir. I miss working with you, Jeff. He keeps me honest. So yeah, so this takes 3, and if we wanted to go bash that together with our add tuple version, we go ahead and we say, okay, first tuple is 0, 0, second tuple is 1, 1. All right, so that seems to be marginally faster. The trick is, though, you'll notice these numbers are changing, and that's why you have to do a whole bunch of these. And we don't want to do that manually. So that's when we use something called Benchy, and there's, I think, a couple of other packages that do it, but we'll use Benchy for our purposes. And what Benchy does is you can go through and you can say, okay, I want to set up just a pile of these tests. And the way we're going to do that is first we're going to set up some data, some test data for ourselves. We're going to use the generator form, for in, in range 1 to 1,000. We're going to just set up some very boring vectors. The first vector is just whatever iteration you're on, and then the second vector is plus or minus 1 in either dimension. No big deal. We call Benchy run. Benchy run takes a map that maps the name of the thing you want to run to a function. And right now we're using these all as arity 0 functions. There's a reason that you might not use those, and I'll talk about that in a second. And then it just says, oh yeah, like here's what I want you, and you just tell it the function to run, it's going to benchmark it for you. So we're going to do add tuple destructuring, add list, and add list destructuring. I'm just going to reuse some stuff that I've already done. And if we look at the way those are implemented, I'm just going to show you so that you're not surprised. Add tuple, it goes ahead and explicitly pulls out the elements here. Sorry? I thought I heard somebody. What's up?
I think somebody just has a hot mic.
Oh, okay.
Could be.
And then, second one is add tuples destructuring. We're just going to go ahead and pull that apart in the function head. Add lists together. Again, same sort of thing. Takes 2 lists and then does a thing. And then final part is, destructuring. So these are very similar to what we already covered, but we're gonna kind of like push them around. And now we're gonna go ahead and look at our thing. So the last part is a few arguments. We have a time. I want to run this like a bunch of iterations for like 10 seconds. I want to make sure that it runs okay. Memory time, I believe that gives it a way of measuring how much time is spent in memory, and sorry, not how much time, rather how much memory is spent. So we get a memory profile, which is very helpful. And then formatters, there's a whole bunch of neat options. So the first one we're going to run is just the console. So let's go ahead and run this and give you all an idea what it looks like when Benchy is firing away. So I'm on a decent workstation from back in the day. It's like a first gen Ryzen 7, so like 16 cores, whatever. I've got like 64 gig memory. Unless you tell it to, it's going to run everything on basically one core, one at a time, so that it's not letting multiple tests mess up each other's results. There are reasons you might want to run tests in parallel, but generally you want to run them one at a time so that you don't have a noisy neighbor problem. And so it's just, chugging through, doing a thing. And it does a little bit of warm up first to make sure that like caching effects aren't a major deal. And now it's going to spit out our report. And yeah. So what we see is that if you add the tuples this way, you get a few more instructions per second. That's kind of cool, I guess. Overall, you get slightly better timing using tuples instead of lists. Great. And in memory usage, tuples reliably were smaller in memory. In fact, like a decent amount smaller, especially if you're doing like hundreds of thousands of these. Yeah, so we have now done a benchmark. If people would like, we can go ahead and we can just really quickly change one of these to use our reduce method and see what that looks like. So if people are curious, we can do that.
Yes, please.
All right. So let's go ahead and we're going to, let me just grab this. Self-plagiarism is the highest form of plagiarism. There we go. We're going to go ahead and we're just going to do our pretty boring ones, except this time we're going to make two changes. First, I'm going to let us use the HTML formatter because I just want to show it off because I think it looks really slick. And then what we're going to do is we're going to do add reduce. And this time we're going to do, tuple mesh dot add reduce AB. Cool. And up here, this is a tuple just because that's the convenient way of storing them up here. That doesn't actually filter down into how they're being executed, in case people were curious about that. So now that we have that set up, we're going to go ahead and run this again. And this time when we run it, he says with hope in his heart, we're going to have an error because I can't type. And that's pretty cool. I like that. There, I had an extra parenthesis, classic extra parentheses. So LFE is not the language for me. So it's going to go, it's going to, and I think it's going to get mad at us. Oh no, it's not. It's not going to be mad at us. Okay, I'll take that. I was worried that in my haste of copy and pasting, I fed it the wrong type of test data. Cool. And so now I want to show something else that's pretty slick. Let me pull this over here. I said, let me pull this over here. Firefox, let go of it. It's not yours anymore. Come on. There we go. All right, so we use the HTML reporter. And so here we see that reduce is like markedly slower, right? Like, oof, which is a shame because it's like the more elegant, pretty functional way of writing it, but it's also wrong. This is common in numerical stuff. The pretty way is not the right way. The fast way is the right way. Not only is it like not the right way, it's also uses like 4 times more memory, which is also very sad and pains me. But we can go ahead and look at our comparison, and they actually give this nice, pretty version here. And then I think when it finally decides to do it, it also has like nice, pretty. There we go. Come back, come on, Benchy, come on. This is the web browser's fault. It's not their fault. It will actually give you nice, pretty graphs. Somehow, he says with open his heart. I usually just stick to the console one. You can also do JSON as a formatted. But yeah, here. So now you get this very nice, obvious eyeball, like, oh yeah, reduce is clearly garbage. Like, good to know. So, yeah, that is, in a nutshell, that is how we kind of grind through, thinking about why code might be fast, looking at the output from the disassembly to see which one we're pretty sure is going to be fast, and then finally benchmarking it. And so this was kind of a whirlwind of emotion. I thought tuple was going to be coming in like clearly in the head. We saw the disassembly. I totally changed my story. I'm like, oh no, it's like 5 instructions. It's going to be way better. It's going to definitely be the reduced version is going to be faster. And then we benchmarked it, and it turns out that list wasn't actually as bad as tuple. I mean, they're pretty close, but still, like, tuple took the day. So now we thought about it, we formed a hypothesis, and then we tested it. This is about as scientific as we can hope to be with our code. Yeah. So yeah. Thank you much.
All right.
Appreciate
Well,
everybody.
thank you, Chris. Yes, exactly. We can unmute our claps. Any other questions for Chris?
Yes. So the normal way of handling like vectors is to have a vectorized solution. Is that what we were just doing, or is that something else entirely? Right. So in Python, I use NumPy, and it just vectorizes. It's much faster than individually adding items.
Sure. So there's a couple of things going on, right? One of the big things is that if you're writing this in like C, or calling into C from NumPy or something, what they're going to be doing is they have a bunch of floating point numbers or integers that are stored right next to each other in memory, and then that your processor has instructions that are specifically optimized for taking that out and unpacking it from memory and then doing operations on it. The way that data is boxed up in Elixir and Erlang and on the Beam, really, even tuples, they're like densely packed, but they're densely packed boxes, but they're still not contiguous in memory, so we can't vectorize it. Yeah, so that's kind of like a fundamental flaw of the Beam for numerical stuff. If you look at the new stuff coming out with numerical Elixir, depending on who you talk to, they've kind of solved some of that problem by just punting it over to TensorFlow, which internally, vectorizes it properly and has like nice dense packings. But meh.
I have a question.
Thank you.
Can the host kick me from screen sharing, please?
Yes.
Linux has decided to
sure
hide
I
the
can.
Zoom bar.
More.
And thank you
Stop
very
sharing.
much.
There we go.
Wonderful. I'm free.
Yeah, I had a question, and that was, when should we be precious about profiling performance and making things go very fast?
Very good question.
So I'm of two minds about this. So who here makes most of their, who here gets paid to write web applications?
Like a lot of people, everybody.
So the great rising tide of Elixir was driven mostly by web design. Anyway, grumbling aside, we kind of don't care. And it's okay that we don't care, because we typically, we don't care about performance because we're already doing really slow, dumb things on slow, dumb distributed systems, right? Like if I perfectly optimize my little vector edition, that's great. And then the time it takes, the time it takes Postgres to like go and pull a connection and do a thing and wait on a data center and come back to me and do a thing, like I've lost that, right? Like we're fighting over microseconds, and we're just like throwing away those microseconds in terms of all this other string munging and database stuff that we're doing in web stuff. So is it a big deal? Meh. Is it premier optimization? There's also this question of, if you're truly very, very serious about bashing the stuff together as quickly as possible, you shouldn't be writing it in Elixir, and that's where you get into like NIFs or something, or at least that's where some people think you should be getting into NIFs. However, my argument is that we should generally try to be empathetic towards the machines that we're working on. And what I mean by that is that it's good to have a rough idea in our heads of what's going to be fast, what's going to be the generated bytecode for this crazy stuff we're going to be putting into our systems. And it's the reason that I care about that is that when you write really unperformant code and you're just like willfully oblivious to the performance implications of what you're doing, um, you end up dying by 1,000 cuts, and you end up in a case where like you've got to pay 10 times more to AWS because you've just written really suboptimal code. And like at some point, we do have to pay for it, right? And in the this fiscal quarter, we might have to pay for it to AWS. In 100 years, we might have to pay for it when the world's flooded. So writing bad code you have to pay for it eventually, you or your kids or their kids. I'm very serious about that. Another part of the puzzle is that, in my opinion, when we're trying to decide whether to optimize something, sometimes having very optimal code for like little tight stuff like this, it frees us up to be sloppy and have more room to explore later. It's kind of like, hey, I know that this is pretty tight, so I can just take this for granted. And if I can take this for granted, then I can do some other really, really cool stuff. And if you look at projects like Scenic, for example, if you look at some of the stuff we do with like, hell, look at Phoenix, right? Like we look at the router, right? We kind of assume that like routing is cheap. And if routing wasn't cheap and plugs were not cheap, we would have to approach problems entirely differently. So, all of this to say, I would don't fret over like individual cycles, but also have an idea when you're spending them, and try not to waste this gift of computation that we have.
I will have a following question to that.
Sure.
Which is, so what would be a good way to start like understanding the cost implications of certain instructions or semantics of the Elixir or Erlang? Because sometimes it's just not obvious.
Sure. So what I would say, and this is, so the first thing is, when you go to explore this, you're going on a scavenger hunt. The actual information about how the low level stuff works, maybe Robert still knows. Maybe there's probably some very clever people in Sweden that know, that actually have a truly deep understanding. Fred probably knows, and then like then you're at the end of the list for like the people that actually know all of the beam behavior. Um, so the places to look and the stuff that I think is worthwhile looking at. The first one is you want a basic mental model for how it works, and so I would check out. It's like the Beam Explained Like I'm Five or whatever. I've got a pile of references that I'll distribute as part of my talk next week, but it gives you a very quick overview of how memory is used, how functions are invoked, how the Beam works. Great. There's another one. It's like the Beam Internals book. Again, same thing. And honestly, the Erlang documentation, not the Elixir documentation, but the Erlang like God-fearing, super ugly typeset in like 1983, like HTML files. They actually do have a lot of information for memory sizes for some of these things. A lot of it just comes down to just like the timing information. I think you're going to have to learn how to time stuff, and that's basically go play around with timer.tc and play around with Benchy or your other benchmark of choice, and then you're going to have to profile it based on your specific situation. And what I mean by that is that if you look at Erlang 19, if you look at Erlang 23, or most recently Erlang 24, there was a huge change between 23 and 24. And that was, we deprecated high performance Erlang and we replaced it with this JIT stuff that they were working on, JIT just in time compilation. And so the behavior is totally different in terms of like what timings we expect and some other things. So for benchmarking, for timings, you're going to need to test that yourself. Generally speaking, I would, it might be worth it learning what the memory stuff is like, because these days you're probably going to run into memory problems before you run into like interesting CPU problems. And the memory stuff, again, you can pull from the Erlang documentation. I have a small bonus set of I adapted 3 functions from Stack Overflow that give you different size stuff. You give them a term, and then they tell you what the encoded size is, what the raw size is, and then what the heap size is, just to kind of get a feel for that. And again, those are all in my talk. There's a nice table that I'll present of like, if it is an atom, it is this large. If it is this, it is this large. There's a big difference also in sizes of terms between whether you're on 32 or 64-bit systems. Side point. Is that answering your question? I'm sorry. I just kind of just went chasing ducks.
Oh, that's super interesting. Like now I'm wondering, so we need to go into a scavenge hunt, but I wonder, like, will profiling will be like less costly, like in the sense of like, I have to go read the documentation, understand the data structures, how they are implemented, maybe, or should I just go and profile first, or I don't know, like.
Reading the documentation will give you an intuition for what you should profile. I'll put it that way, right? In an ideal world, we would profile everything all the time, every time. And in some industries, they do. We are not that industry, sadly. But knowing roughly of like, oh yeah, like I'm allocating this many bytes per process. I'm bashing together all of these binaries, and I know how slow that's going to be. I know that maps are O1 access, where lists are ON access, whatever. That will tell you where you need to be profile. Like that'll give you an intuition for where to profile. So I still think it's a worthwhile endeavor. Maybe you don't have to get as far as like reading the source code for the Erlang VM, but like, again, reading our basic docs, I think, is a reasonable barrier to entry to at least put this much stuff into familiarizing yourself with your platform. And then after that, of course, profile. At the end of the day, you have to profile because other weird stuff can give you strange timings that you wouldn't otherwise intuit.
That's perfect. Thank you so much, Chris.
All right. Any final questions? Oh, Jeff.
Sorry, folks. This is more of a comment and maybe an arrow for your quiver, Chris, on my leading question of when to optimize. And I really liked your defense of it. And I'd like to point everyone towards Wirth's law. It's got other names as well, but it's, let me look it up so I don't just butcher it. This is Wirth's law is an adage on computer performance, which states that software is getting slower more rapidly than hardware is becoming faster. So those that death by 1,000 paper cuts is a real big deal. And thank
Is that
you.
Nicholas Wirth?
Let me consult my good friend Bob Wikipedia. Yes, Nicholas Wirth.
You know Wiki? When did he get up to Denver?
My goodness. Moving swiftly on. Thank you, Jeff. All right. Seeing no further questions, let's slide on over to show and tell. Does anybody have something that they'd like to show?
Hey, Roland, do you have anything?
Roland was eager to share a thing.
Yeah, so I had a lot of trouble with, so I like self-hosting, and so I wanted something that does roughly what Calendly does without me needing to be dependent on Calendly to write performance software. They have a lot of JavaScript on their webpage.
I bet they do.
So I put a link in the chat to my demo page. And what I'm doing is I have a text file on my server that includes my time zone, what I think my guest's time zone is going to be, and a meeting length, as well as a TSV of dates I'm available and start and stop times that I'm available. And then it parses it automatically using the date time conversion functions I showed earlier into potential meeting times. And so all I have to do is upload a new file to my server, and it'll render into one of these pages. And it uses query parameters to switch time zones. If I guess incorrectly what time zone you're in, like you're showing up at the Denver meeting, but you're actually calling from the Pacific time zone. Okay, I set you the mountain time zone, it's the wrong one, switch over. But what I found interesting about this is that I built it on top of INO, which I think is inoweb.dev, which is an experimental HTTP library built on top of Erlang's Elli, E-L-L-I, which is a lightweight, microsecond fast HTTP library built for static rendering and APIs, and really nothing else. And so all you're doing is taking a token, doing a functional transform on it, and sending it back to the person who called for it. And because I had such direct access to the internals, I was able to really easily say, okay, let me grab the path from that, grab the file, parse it, render it in HTML, and send it back, all within, I think, 7,000 microseconds or something from the mid, and I'm in the middle of the Pacific Ocean. So if it's rendering that quickly, it's quite impressive. And if you'd like, I can show some of the code, although I didn't prepare that ahead of time, so you'll have to give me a little time if you're interested in that. But I just found working with INO really interesting because it's like raw HTML. Like, here's a token, now add a response code, now add a header, now add a body, and send it back. It reminds me a lot of Sinatra in Ruby relative to Ruby on Rails, or Flask, although I feel like it's lighter than both Sinatra and Flask, just by the nature of Elixir.
Sure. I mean, with this, is the code handy, or is it going to take you a while to get there? And if not, do you?
I mean, I have to open a terminal and find it because I didn't have it prepared, but I have it. Give me a moment.
Clicking on your demo. Oh, cool.
So, okay, Zoom, you can tell me that they can see my application, so I can't see my own screen.
There we go.
So the meat of this is a handler. So it receives a token, and I decided to be clever so that I didn't have to recompile my application every time I uploaded a new invite. And so what I'm doing is on my server, I'm checking in the invites folder for the text file, grabbing all the files in that folder, taking just the path name, and turning that into a route using the get function provided by the INO library. And so if I upload a new file to my folder using rsync, my application, without restarting, will automatically render that into a link. And the moment I remove that file, it will return 404. Actually, it returns not found because that's the default of the LE library that this is built on top of. And then in my now increasingly badly named index, I'm setting a response code, telling it that I'm sending back HTML, and then calling an evaluation function, which is grabbing that path name, opening up the file. I guess we can go to invite create and look at that. I think it's this one. So it's grabbing the path from the token, and then it's parsing the file in question, both the header and the TSV below it. And then it's setting the guest time zone, giving media duration, and all of this is just converting those tab separated values into the dates and times I need to render in the embedded Elixir template. So this is poorly named because I haven't gotten around to refactoring this, but all it's really doing is building it into a format that the converter function is expecting, converting it, splitting up the amount of time that I have available into half meeting duration chunks. So if my meeting duration is set to 60, it sets meetings every 30 minutes up to an hour before the end of my availability time. If it's a half an hour meeting, I'll do 15-minute chunks. And then I convert those into appropriate dates. I group them by date so that I can get the rendering style that you see on the demo, right, where it's major date and then times. And then I sort so that they're in the right order. By default, it'll put 10 before 09. because it's 1-0. So I have to sort by date, and then I'm just formatting them into the date time strings that you see on the web page. And I'm just wrapping that, then I'm rendering it in Elixir. So going back to here, I'm using this render.render is just a wrapper around the EEX function from file from my template and passing in all the values that it needs to render. So it compiles so it compiles the EEX at compile time, and then it just calls that compiled function each time that there's a request. I found out because I was using the evaluate function before I learned that function for file existed, that Elixir caches the embedded Elixir. So it would take like 4 seconds the first time to render, and then it would take 10,000 microseconds after that every time because it just kept it in memory, apparently. But this eliminates the need for that entirely. So that's my application for the most part. And then if you want to look at the time zone converter, all I'm doing is just parsing a map that contains all my stuff, and then just calling that a datetime new and a datetime shift zone and giving it back to myself so I can use it later. And that's all I have.
That is cool. Thank you. Any other questions, comments, or things that other people would like to share? All right, well, we've got the link to the demo there, which is pretty cool. Is the code on GitHub? Is that, do you have it out there, or is it a?
I'm working on open sourcing it. It has not been open sourced
Okay.
yet. Wanted to clean it up a little.
That's fair, but yeah, cool project. Thanks for that. All right, anyone have anything else he wants to share? Otherwise, I will toss open a couple of rooms and we can hang out as long as you would like. All right, I'll try 2 rooms and you can choose where you go. And with that, oh yeah, stop recording, stop.